like them sugar.
Oh, please. Katie, I have to go back to work now, okay?
Okay.
Wow, it's pretty bright up here. Looks like a pretty highly reflective roof system.
Yeah, these roofs are great for summer and high heat.
Uh-huh.
What we got here, this is the vent for the clothes dryer.
Okay, dryer.
This is the water heater flue pipe. And then this is the upper combustion air for the water heater, which is also connected inside the attic.
Okay, and I see another vent over here.
Yeah, let's take a look at this. This vent here is for the furnace that's inside the closet. And then this is our upper combustion air. Remember when we were downstairs, we're connected from outside to the attic, to the upper combustion in the closet, and then into the house.
Gotcha, so this is directly over the furnace that was
Correct.
next to the fireplace.
Correct.
Okay, and is this the evaporative cooler?
Yeah, this is their evaporative cooler. They haven't used it since they've lived here. It's pretty rusted out.
Yeah, I see that.
So it's time for this to go away.
Okay, now does this operate on the same ductwork system as the AC?
Presently it is, and they're two different systems. Air conditioning and evaporative cooler need different styles of duct system, so they really should have their own duct systems.
Okay, now can't you also operate an evap cooler through a window or a wall and eliminate the ductwork?
Yeah, that's correct. But what you want to make sure is that it's sealed in place and that you can seal the opening off when you go to the AC system, you know, so you're not adding an extra hole into your envelope.
Gotcha. You said you wanted to show me something on this facade over here?
Correct. I've walked the perimeter of the whole house, and the only other attic venting that I could find is underneath this. This is all screen under here.
That's it for the whole attic?
Correct.
The only vent?
The only vent.
That can't be good. Holy heck, what is that?
Okay, how about just one more puff?
Okay.
I just want to see Charlie's face when he sees all this smoke coming out.
You know what, have you seen Jill?
No, I haven't.
Okay, back to business. Okay, so what this is doing is this is checking for duct leakage, right? This is the blaster?
The duct blaster, right.
Okay.
Yeah, this is used to measure duct leakage. But in this system, it was so leaky that it couldn't even get accurate readings with this system.
Okay, so where we have leaks, you can actually start to see the smoke throughout the house.
Correct.
Okay.
Yeah, in this system, what the builder did was, although he was building as builders built in those days, he used a lot of systems that didn't have a longevity, like this old duct tape. As you can see, it's just dried off and fell off.
You can see it starts to turn to powder, and then that's what causes the leaks.
Right.
Okay, what do they use now? What do builders use now to seal their ducts?
We prefer mastic. Mastic is a material that has very long lifespan. It's pliable and very forgiving when you're working in an attic. It's easy to put on. It's hard to mess up.
So where were some of the leaks that you found in the house?
Well, we can't get into the attic to find all the leaks, but we have found some big, obvious leaks.
Okay, such as the evaporative cooler I know on the roof.
Correct. In the evaporative cooler, there's a damper designed to keep the air conditioning air from getting into the evap cooler. And the evap cooler may have corroded that open, and it may be stuck open. We just need to go up and look.
Okay. I know Charlie and Ken found a big hole between the return air platform and the chimney, too.
Correct. It's a big hole, and that may be the main reason why we can't figure out the leakage with the duct blaster. It's our big hole.
Okay, sounds like we should seal off those holes and then maybe retest the system?
Right.
Okay, how about if we go see if there are any other obvious leaks?
Sounds like a plan.
Oh my gosh, it looks like a blues bar in here.
It sure does.
So what do we have going on? Obviously there's some leaks.
Yeah, this return system, as we were discussing before, is connected to all these interior walls. So it's pulling air from all over the house. As you can see here, it's just leaking right next to the chimney here.
And I see it's coming also from the opposite side of the chimney.
Right, these returns can pull air throughout the house because of the interconnections of the walls.
Okay.
So you don't know where you're getting your air from sometimes.
So it's probably a mess in here. We can see leaks coming from all around. Let's take a look inside. Oh my goodness.
Yeah, this is also leaking quite a bit in here. There's, looking at it before, there's some penetrations through the platform that are leaking, and there's some old tape up there that is dried out and falling off.
So we have a lot of sealing to do.
We do. What we're going to do is replace this system, retest to make sure that all of these are sealed up properly, and just see where we are with the rest of the system.
Okay, we've seen everything we can see here. Let's move on.
Okay.
So, Charlie, it looks like really between the duct leaks and the house leaks that these things can be fixed pretty inexpensively.
Exactly. That's the beauty of weatherization. There's a lot of things you can do to your home very inexpensively and get a really nice return on your investment. For example, a duct leak is probably one of the best investments you can make on your home.
So what would be the next highest?
Balancing your room pressures, making sure you have sufficient insulation installed correctly.
Okay, so we've got room pressurization, insulation, duct leakage. Those are 3 items, and then it goes on to the equipment.
Right. Once you get those taken care of, then you can start taking a look at replacing any inefficient equipment you may have.
So how long does it take for these fixes to pay off?
In a lot of cases, they can pay for themselves in 1 or 2 years.
Great, let's look at some of those expenses.
What we have here is utility bills for the last 18 months for this house.
Not too bad.
A rule of thumb that we use is you take your 12-month utility history, find your 2 lowest months, average those 2, and that will give you a pretty good idea of your base loads.
Okay, and your base load would be any of your daily uses minus heating and cooling, such as showers, usage of base electricity, cooking, various things like that.
Right.
Okay, so if we were to take that 116 times 12, we have 1392.
Right, and then you take that total and subtract it from their total utility bill, and that'll give you what they spend on average for heating and cooling in a year.
Okay, which ends up being about $833 a year, not too bad.
Right. And again, this was a pretty mild year, and they've been telling me that they do an awful lot in this house, try to keep their bills, in control by opening the windows when they can to take advantage of cool night air, using ceiling fans, just a lot of the little tricks that they use.
The homeowner mentioned too, they get a lot of cool breezes coming down off the mountain. They're able to use that to balance out some of their heating and cooling.
Right. Why don't you just follow me? Ken and I have a plan to cut these bills even further.
Okay, sounds great. So guys, it looks like you might be plotting the end of energy consumption.
Well, you know that energy reduction is usually a lot less expensive than energy production. Ken's got some real good ideas here he wants to tell us about.
Yeah, so here's the deal. We've been talking about our thermal envelope, which is our livable space. And what that consists of is your walls, your floor, and your ceiling that all are insulated like an ice chest. And we have some problems. We've got some holes in it.
Uh-oh.
Yeah.
It's like your beer isn't going to stay cold.
Exactly. So what we want to do is we want to take your envelope and move it from the ceiling right up to the roof deck.
Really? You can do that?
Now, with the way your home is designed, we can do that.
Yeah, the one thing I noticed, and you really have these things working to your advantage, you only really have 3 holes in your roof deck. You have the combustion vents for your furnace, for your gas water heater, and then you have that one vent in that Spanish facade out front, and that's it.
So if you seal those off, really your problem is gone and there you have your envelope.
And what that does is all of those supply leaks that we can't get off because of your flat roof, by moving that thermal barrier up to your roof deck, they become part of the house. They're inside the thermal envelope now, so they leak into the house.
And if you can imagine, all this air is going through your ductwork up there, and on a hot day in Arizona, we're trying to blow that cool air through an attic that's maybe 160 degrees. Okay. Now, once we do this and move the insulation up, extend your thermal envelope, now that ductwork is in conditioned space of maybe 100, 110 degrees on that same 100-degree day.
All right, so essentially then I got kind of like my thermos, but I'm actually kind of building a thermos outside of my thermos.
That's correct.
Okay.
Another thing that's really going to help you is on the roof itself, I noticed some real signs of wear. So you're probably going to have to do something with that real soon anyway.
Great.
So what I suggest is add another 2 or 3 inches. Now you got a solid roof surface. We'll make it reflective again. So you're going to get a little bit more reflectance off of a new roof, and it's going to add to the thermos effect, keeping that ductwork in a conditioned space.
Okay. All right. Well, I guess I should talk to the boss tonight about this.
Maybe bring her a glass of wine. That always helps.
Yeah.
Yeah, but not if she's pregnant.
Good point.
All right. Yeah. Okay. Well, I'll talk to her and we'll see if we can get this started.
Great.
Sounds good.
Thank
you very much.
You got any beer?
I do have some beer. Let's go to town. It's been a long day.